So, questions from yesterday's multiple choice section? Number 2.
So we did it 2 different ways and still got the same answer. Not saying our.
I wasn't sure if you could do low cat.
Okay.
Or conjugate.
Yeah.
So just looking at number 2,
I didn't.
it looks like conjugate. Of course, first let's plug in 0. Make sure 0 over 0, which means it is eligible for L'Hopital's because it's 0 over 0. So this could be one where you work either way, L'Hopital's or conjugate. Which way did you want to do it?
Conjugate.
One vote for each.
It's easier, dude.
I think L'Hopital's might be easy because the derivative of the bottom is just 1, so that'll be easy. So let's try L'Hopital's and see if it works for us. Because we get 0 over 0, so we'll try L'Hopital's. Derivative of the bottom is 1. Derivative of the top would be that, which I guess if we clean that up a little bit would be 1 over 2 square root x plus 9. And then we can plug in 0. So we get 1/6. Did you get 1/6, Tyler, using the... Okay. And so if you use the conjugate method, you get 1/6 as well. So this was L'Hopital's rule. Or conjugate, either one.
Mr. Wolf, can you take a look at my work and see if I did it right, if I'm supposed to do it like this? Because I didn't move it over like that.
4 and 7.
4 and 7? Okay, number 4.
Oh, yeah.
Limit as x goes to 0. So the sine of 1 over 0, the sine of a really, so that's the sine of a really big number. As sine gets bigger and bigger, or as x gets bigger and bigger, sine just keeps oscillating. So this is not going to have a limit, non-existent. The reason would be is it oscillates, but the answer would be non-existent. Non-existent. It is undefined, but we're not at 0. We're getting close to 0. So 1 divided by close to 0 is really big. Getting bigger and bigger. 7 is real similar. 7's kind of tricky. I don't think they would do this on the AP test. Limit as x goes to infinity. Well, sine of infinity as numbers getting bigger and bigger. I mean, even way out there, the sine graph still just oscillates. So this one's tricky because B is a true statement, but the answer to a limit is not oscillates. The answer to the limit is D and E because it oscillates. I don't think they would put answer choice B on the AP test because it's a true statement. It's not technically correct answer to this problem. So that's kind of tricky. By the way, I've now posted the answers to this packet in Schoology, so you can check them. Questions on the back, or was the limits easy once you remembered what was going on with that picture? That was like the very first test. Which one? 13. 13's a good one. So the limit as x approaches negative 3 from the left and negative 3 from the right is both negative 1. Maybe a picture would help. So as we approach negative 3 from the left or the right, so it doesn't really matter which way we come from, the limit there is 1, negative 1. But the function is not defined there, so there's like a hole there. There is a hole there, not like a hole, there's a hole. Because the limit exists, but the function does not. So which of the following statements must be true? The limit exists. Yes, if the limit from the right and the left equal each other, then the limit exists. So that one works. Part 2. F is continuous everywhere except x equals negative 3. Well, I mean, it's true that f is not continuous at negative 3, but we don't know what else is going on here. So this everywhere business, I mean, this could be an asymptote, and we could have a jump discontinuity. Like, we don't know what else is going on, so I can't say anything else about stuff elsewhere. All I know is what's going on at negative 3. F has a removable discontinuity, meaning if I fill the hole, a fixable discontinuity. Yeah, if I filled that hole, it wouldn't be discontinuous anymore. So I think it's 1 and 3.
Our choices were A or B. We're going to consider these.
Other questions? 5 and 6? Yeah, they are. They're very much the same, yeah. Very similar.
After that, can you do 8 through 12?
Let's do 5 and 6, and then do you really need to do 8 through 12? Okay. So 5 or 6, which one would you like?
Yes.
They're kind of, you're right, they're kind of the same. Let's do 5. So I think I want to rewrite that as x plus 1, x minus 1 over x minus 1 is what this is. So there's a hole there at x equals 1, but we don't use that if x is 1, so we're safe to kind of mark that out. So that's a graph of x plus 1 when x is not equal to 1, and x equals, or y equals 4 when x equals 1. The limit as x approaches 1, f of 1 definitely exists, because that's 4. So I can definitely say 2 is true. F is continuous, or the limit exists. I need to be careful here. So at x equals 1, I think there's a hole there. It's the graph of y equals x plus 1. So that would be, let's see, plus 1 and then up 1 over 1, although there's a hole at x equals 1. And then this says when x is 1, y is 4. So there's a picture of this graph. Now these questions should be easy, I think. So the limit as x approaches 1 of f of x exists. Is that true or false?
Yeah.
That's true. The function does not, or the function is not continuous, but the limit does exist. So 1 is true. The limit exists. F is continuous. No, it's not continuous. So 1 and 2 are the answers. And I bet 6 is similar, except that this one, in fact, it's the same x plus 1, same graph, but when x is 0, y is 1, so that fills the hole. So yes, f of 0 exists, yes, the limit exists, and it happens to be continuous because they filled the hole in. So yeah, 5 and 6 are real similar, but 5 didn't fill the hole and 6 did. All right, today's assignment is, I put these out of order, so pardon that, but you can flip to multiple choice topic 2, derivatives. And most of this is just take derivatives all day long. So, work together, ask me for help, lots of review questions, but this is today's assignment. Work through that.